Daian-ji Temple is located in Sakai City, Osaka Prefecture. The Hanka-Kaikai Association is currently carrying out repair work. This temple, known as Soso, was founded during the Oei period by a special monk. The original location of Daian-ji Temple was about 800 meters north of here, but it was destroyed in the Battle of Osaka during the summer siege. It was said to be relocated to its current location around the Heian era. This is the grand entrance at the northeastern corner of the building. Even with the previous structure, it is known that there was some kind of connecting building here, but the exact form is not known in detail. It is not clear what it looked like. Looking west from here, we reach the current northern corridor. Passing through the corridor, we come to the easternmost room, which is the 6th tatami mat room. The room is decorated with a painting of a crane. It is a 6th tatami mat room. Though nothing remains today, originally there was a partition here, separating the 6th tatami mat room and the 12th tatami mat room, the lower room of the hojo. This was referred to as the lower room. Heading south from here, there is also a partition, and beyond it lies the center of the hojo. The 18 tatami mat room and the 7 tatami mat room are the most central rooms of the hojo. This section to the east is the Buddhist hall, with a Buddhist altar located at the back of the room in the current floor plan. This is the current layout. There is a partition here, and the back wall is the dividing line. Behind this wall is the upper tier room. There is an upper tier room, and above it, the floor of the upper tier is situated. Behind the wall that separates it, you will find the current tea room. This is the southern corridor. At the southern end, a south garden was added in the early Showa period, and it has now been removed due to changes to the current layout. As a result, the two-column space was subdivided, with sliding doors and a ceiling attached to the outside in the new arrangement. The space now features a new partition and a ceiling. The materials used here are all about preserving the natural qualities of the wood. Much of the material from the previous structure, before the Tenna era, has been reused in this building. For example, the pillars here are made of Hinoki, Japanese cypress wood, with fine materials from the Ito Masa region used for the finer parts. Almost all of the materials, including even small pieces from the earlier structure, have been brought here and incorporated into the construction. It includes even small leftover pieces. This pillar is on the north side of the 6th tatami mat room. This pillar is a supplemental pillar from the Tenna period. The base of this pillar has been replaced with stone in later periods. This time, we are performing a root repair. This pillar is also believed to have been sourced from the earlier structure and incorporated into the new construction. The base of this pillar has been wrapped in a protective casing and joined together, though the inside is quite decayed, so this time, the root repair will be done from beneath the floor. The pillar has been encased in this manner, but since the inner part is also quite deteriorated, we plan to perform a root repair from underneath the floor. This will involve a method of root repair. In this case, since the material used for the pillar is at the very end of the piece, some of the pillars may not be usable. But we plan to use some of the materials from the unused pillars to carry out the root repair. This pillar is damaged not only at the base but also further up, so it will need repairs at both ends. The part of the mortise for the collar is also damaged, so we plan to repair this area using smaller materials. We are planning to use smaller materials to fix the damaged parts in this area. As much as possible, even the materials that are not used will be repurposed, either for the roof or as small parts. We plan to make use of them in that way. Now, let's take a look at the root repair and the upper damaged sections. First, we will smooth the uneven cut surface of the small material. This is to ensure a good fit with the root repair material. This is the marking of the root repair material. We've adopted the cross-tenon method. This root repair material is made of new materials. Yes, that's right. The original material we planned to use for the column had a slightly smaller diameter, so this time we are using new material for the repair. We are using new material for the root repair this time. For the root repair, we decided to make the connection under the floor to preserve the old material as much as possible, and thus we have adopted the cross-tenon method, which has fewer joints. This method uses the least amount of joints to preserve the original material. Naturally, we are using the same type of wood. Yes, that's right. We first check the fit and then refine the joint by remarking it, checking the degree of fit, and reshaping if necessary. This is the reference diagram for the small and new materials. Yes, that's right. We are removing the markings. That's correct. When joining the small and new materials, the small material is already aged and dried, so it won't shrink. However, the new material will still shrink, so we made it slightly 3 mm thicker than the small material for a proper fit. We make the new material slightly thicker to account for shrinkage compared to the dried small material. Since the fit isn't sufficient yet, we will remove more material to improve the connection. We will refine the fit on all 4 sides. That's correct. Is this wood glue? Yes, this is woodworking glue. Since this isn't an area exposed to wind or rain, we are using this glue. We check to see if the markings align. If all 4 sides align, next, we will look at the repairs to the upper part of the column. The walls have been damaged by leaks, causing them to rot, so we are repairing these sections. We will cut out the damaged part and use some old material that fits well to repair the upper section of the column. This is a Kanawa Tsugi joint, right? Yes, this is a Kanawa Tsugi joint. This is a Kanawa Tsugi joint, correct? Is the Kanawa Tsugi joint a particularly effective method for repairing the upper part of the column? Yes, that's right. It's strong against pulling forces with screws, so in various ways, the Kanawa Tsugi joint is more effective, which is why we adopted it. For Kanawa Tsugi joints, you don't use adhesive, correct? That's correct. We insert the screws, place a line in the center, and improve the fit between the two materials. Next, let's take a look at the method for heat bonding column materials on site without removal. This red line indicates the cutting surface. Yes. When performing heat bonding while standing, we jack up the column and lift it by the amount of the tenon, then cut off the lower part and insert the new material. We cut off the lower part and inserted the new material. Now we are removing the old material and planing the part that will fit. Next, we remove the template and match the template to the heat bonding material. That's correct. In this case, since the old material cannot be used, we will perform the heat bonding with a new material. We will align both the upper part and the stone foundation, and then refine both parts. This is the blade repair. This material has insect damage in the small paper section, so we decided to use old material for repairing the blade. First, we are cutting the damaged section. We are leveling the bonding surface, and here is the marking for the dowel holes. We've dug the dowel holes. We have also drilled screws where the blade's edge meets. Now we are using old material to remove the damaged part. We are inserting the dowels. What is the red substance? The red substance is a wind and moisture protective agent. Since we cannot apply it to the bonding surface later, we apply it beforehand. This is where we are trimming the dowel ends. We are smoothing the dowel ends to fit the hole. We have attached a pin at the front and a screw at the back. We lower it, then insert it into the dowel hole and adjust the position. This helps prevent lateral shifting and pulling forces. Now, we are trimming to fit the blade surface. We are attaching the core material slightly raised to ensure proper fitting. This is the repair of the horizontal member. This material had broken where the column was attached. We are marking the broken area with a pencil. We are cutting out the marked area with a pencil. Is there a reason for the angled cut? It's partly for aesthetic reasons, but also because when there's lateral shifting, the angle creates friction, and since the cutting face is angled, it's less likely to peel. The angled cut helps prevent peeling by providing better contact, both at the surface and in terms of depth. Now we are adjusting the fit and making fine adjustments. Especially for this horizontal member, since it's the oldest and original material, we are trying to preserve it as much as possible. We are making this repair with that in mind. All materials are planned using this approach. We use wood screws to ensure a strong bond between the materials we've removed. By pulling them together with wood screws, we secure the materials. We also bond it with woodworking glue. The nagesi joint is attached to the post with a collar. So this section will be nailed to the post, meaning it will hold securely. It has been slightly raised. I believe you can see the collar notches on the backside. This time, we replace the severely damaged beam with new material. Therefore, we reprocess filler wood into the beam support joint area at the rafters base. This is the new beam that will be installed. We are now marking the joint with the base of the rafter. We are shaping the beam support to match the new process material. Using the imprint from the template, we are marking the joint. This is the old beam, and a white beam had been inserted on the eastern side. When tapped, it made a dull, hollow sound. This is the inner part of the joint area at the base of the rafter. We are shaving the joint to fit the new beam. This is where we are fine-tuning it with a light finish. Similarly, we are fine-tuning the outer side as well. After centering it, we are measuring the dimensions for the fine finish from that point. Now, in the upper section, we are creating the Watariago cross-joint projection. We are also creating a projection for the new beam being installed. This Watariago is used to prevent lateral movement. For the aged finish, we use gunpowder residue and tea powder dissolved in water for coloring. As part of the weatherproofing and anti-corrosion process, we apply a complete surface protection treatment. The new beam is being lowered into the Watariago joint. This stops the movement of the rafter base and connects both ends of the rafter base. The repair work on the main hall of Daian-ji Temple has been carried out. It is nearing completion. Soon, it will be restored to its appearance from the construction during the Tempio era.